The Orb of Thundera. Hi, I'm Andrew Armstrong. Welcome to the back of this Teardown lab. We're resuming our project. And our project, where we left off, if you recall, we had just tested our LED and we had used the bench power supply to get the blue channel running through this transistor via the battery pack to this circuit. And what we were going to do is make a circuit that we can use on this booby board. So what we're going to do is dismantle that and put it aside. And while I'm doing that, I'm just going to sort of describe to you the process I'm going to do right now and the steps we're going to take. So you can see the booby board here has a number of pins and it's already got a pin header soldered on. So I'm just going to use a bit of Veroboard. And Veroboard is a copper tracked board which is really useful for prototyping. It's a bit like breadboard but a more permanent sort of breadboard basically. And we're going to sort of just hook that up because the pin spacing on a booby board, which is what that blue board there is designed to use breadboard. But I don't want to waste the whole board, so I'm just going to push this aside. We know what we're going to need to do. So we've got, if you can imagine, actually technically you can mount these on this side of the surface if you want, but realistically you should be doing it on this side. But we're going to put like our booby board somewhere like that on the end, and the booby board's nice because it's got power rails and stuff, so we can use that in some future project. And then we're going to need to work out where we're going to put the resistors and transistors and whatnot. I can tell you one thing though, we've got output pins from the booby board and we know the output pins from the booby board are going to go via resistors like that. So we're definitely going to have something like that, and we know that the resistor is going to be going to the base of the transistor, which is that little middle leg I've lifted up on that guy there, that little middle leg. So there's no massively convenient way of running it inline, and then we're going to have to do a power rail for the actual 20-30 volt power rail for the actual LEDs themselves. So we're going to contain everything in this area. So I could spend some time working it out, and I think I will. I'm going to work out the circuit real quick, and then that way, what I really want to do is just chop the board. I don't want this massive board. What I'll tend to do then is just use one of these sorts of Sharpie type pens and just trace out what I want, and then I can cut out the board. Sometimes I just cut out the board and make it fit, so you've got lots of options here. But yeah, I'll jump cut now and let you know what I decided. I finally came to a decision, guys. Yes, I finally came to a decision. I got bored with the notion of trying to work this all out, so I decided I'm just going to cut the board at some sort of arbitrary length and I'm going to make it fit. So that's typically how this goes, you know, when you're doing rapid prototyping. You can spend a lot of time thinking about this and or just go with your gut, and hopefully your gut's right. Often your gut's wrong, but the more you do it, your gut will get righter more oftener. So that's how I'm going to play this. So I've got my Veroboard. The best thing to do is actually to go and cut it properly with like a saw or something. And we're probably going to do that actually. But you can get away sometimes with doing stuff like this. And the reason that you probably won't on this case, because it's quite a wide piece. If you've got a narrow piece like that, you can kind of just snap the lengths. But what I'm going to do is I'm going to score this anyway, so that I can see what I'm doing. And there's lots of tricks. If you've got this and it's single-sided, you get it double-sided if you want. You can do kind of tricks like if you've got a drill bit. This is the whole sort of purpose of this, and I do have some drill bits here, but neither of them are quite right. The idea is that you get a tool that's a bit like a drill bit and you can twist it in place, and I'll show you that when I start doing this properly, and you can cut the tracks. But if you've got the same sort of tool, you can plunge it through all of these and you'll make this board very weak, and then you will be able to snap it. But for me, I'm just going to nip over to the sort of garage and just run a junior hacksaw down one or both of these, and I'll bring it back and then we'll work on that little bit of board. Got the little junior hacksaw here. You must have one of these in your garage, I'm sure. And I did it on the bench. At the moment I'm using it just in my hands, which is not quite as optimal, but you can see it's pretty easy to cut. Just follow your lines, take your time, and you'll get through it. Away it goes. Let battle commence. Now that dust, by the way, is probably fiberglassy stuff, so be wary of it. This drill bit is this is a small drill bit, will almost do the trick. So I'm going to show you how you do this thing. So if you've got some sandpaper, by the way, feel free to rub it on that edge and get that a bit, you know, bit smoother, less scratchy. I'm not, because I don't care. So first things first is I'm going to position our booby board on there, and I'm going to just solder it. Maybe I could have done a better job making it. Could take that bit off, but I'm going to leave that. Now the pins I want on a booby board. We have a bunch of I/O lines. This is a pick. That's the wrong pen. This is a pick. 16F. 16F 688. You can get the data sheet from Microchip's website, Arizona Microchip. And I've indicated on the board all of the output pins directly. And I'm going to use these 4 pins, RA0, RA1 and RA2. I said 4 pins there, didn't I? I meant 3. RA0, RA1 and RA2. So we're going to solder those ones, and we're going to solder a ground. And I'm not going to solder the rest for 2 reasons. One, I might want to take this off this board, and I don't have a pin header. Otherwise I could just clip it straight in. That would have been the most sensible way, but yes, I don't have a pin header. You can buy those. You can just clip that board in. That's how it's been designed. And 2, that way it's going to be easier to follow which ones I'm working with, because you can see then really which ones apply. So I've just stuck a little pin there so I can mark where I'm going to solder. So I'm going to solder this one, and that's RA0, and then the 2 either side, that's RA1 and RA2, and then we're going to want a ground, and I'm going to solder one of these, which is a ground, and we have another ground over there just in case we want to use that one. So there, it's nice and simple. Going to zoom in now. Let's see if we can turn this so you can see it nicely. As we are prototyping, we probably could have just built this circuit in sort of free form, you know, like soldering on these pins, but there is a sort of level of quality you need in order to be able to debug your work properly. So I'd always advise using a bit of Veroboard or something like that. Just at least you're taking out some of the randomness when it doesn't work. So just applying a bit of heat there. I'm just going to hold it because this is the first pin, and it gives me the opportunity to make sure the board is sitting kind of flat. You see, I don't want it bent too much, kicked up, so that's sitting quite flat. So now I'm going to solder those 3 pins that we're particularly interested in. And that's pretty much it. Now what's very important on the pick, or anything you use Veroboard, is that you've soldered to these pins. So that means that these tracks now are almost extensions, of those pins. But you've got these ones here sitting in these pins that are, you know, potentially going to cause a circuit, yeah. And we might want to use these later anyway. So what we might just do, and I'm going to take our little straight edge here, and I'm just going to run this line across here as a delineation so you can see it. So you can see quite clearly I've got a line across there. What I'm going to do is break the circuit between those 2, and how I'm going to do that, I'm going to take a drill bit, and probably this one. I'll hold it up at an angle so you can see what I'm doing, and I'm going to just very gently, I'm going to do it on the right hand side of the line to give me a bit more room, very gently just twist the bit in the actual hole. That end one's a bit trickier, but I'm going to do it a couple of times and I'll show it up to the camera nice and close so you can see what I've done there. I'll blow away the dust. So now you can see there's a break in the circuit between these 2 sides, so there's no opportunity for a short from this side to this side. Which is kind of ironic really, because that second pin is a ground that I actually intended to solder, but let's not worry about that. So I'm going to do this. Actually, I'm actually going to do it all the way across, even to these 3 pins, and you're going to say, why are you going to do that? It'll be very clear in a moment why I'm going to do it for those. So they've all been drilled out, and actually what I did is I ran a file. I went a bit nuts and I actually ran a file down this channel too, just to sort of really exaggerate the fact so you can see clearly on camera that there's no circuit between these 2 sides. And the reason I did that, and you're saying, well, don't you need these 3 pins? is that each of these 3 pins needs a resistor anyway, yeah? So we're going to be putting a resistor into somewhere else on the board. And what I thought was, instead of trying to constrain ourselves to working within these 3 pins, it's equally just as valid and easy for us to work out how we're going to connect our transistors. So for example, I'm just going to give you a rough example because I'm going to have to work this out really off camera. There's a bit of art here you need to do, where the transistors are going to sit on our board. Because we can actually position the LEDs, the resistors anywhere, because they're almost like jumpers. So we can go, say that one's straight across to there. If we want to just sort of have one that goes from here to here, you can see we can leave the legs quite long. Just going to bend that. Leave the legs quite long and then just work it out. Do you see what I mean? Just like that, just between the PCB. So we can actually just bridge these wherever we want. So we're going to have 3 of these coming out. And then we're going to have, you know, basically 4 pins. Yes, we're definitely going to have 4 pins here. We'll have a terminal on here somewhere as well for the 30-volt line. And that's it. So let me just work out how I'm going to do this. I'm going to draw on the board. That's basically what I'm going to do after scratching my head. Draw on the board and then we're going to build it. Right, so I've had a little bit of a think, but not a massive amount, I'm going to say, because it's so tricky. To be honest with you, there's not really much in it. You can try to make this very neat, but there's no point, so I just thought I'll just spread them out. These are the 3, let's just solder them up. I think we'll work it out as we go along. Best way. So we've got these 3 components and they're a bit loose in there. It's not like a sort of custom PCB. You might be able to just about see the pins. There we go. It's a bit loose in there. So what I'll sort of advocate is really just doing a tack solder on one leg on each one, which I'm going to do right now. And be careful with the Veroboard. It has that tendency for the solder to spread. So if you're trying to just put that solder in one little spot, it has the tendency to work its way down the whole copper because you don't have those nice sort of copper pads layouts for the copper to sit and form a little puddle. It will just run away. So I'm just taking that tiniest amount of care just to make sure they're sitting nicely, and they are. It's good enough. And we're just going to solder those in. If it's an old bit of Veroboard, maybe a little bit tarnished like this one is, you can see it's having a little bit of trouble soldering. So before you do any soldering on it at all, if you've got like a Brillo pad or something in your sink, just give it a rub over it a few times and give it a good wash. You'll know it's right because it'll be nice and shiny. So we're just going to cut away those feet. Cut away those pins. Feet. And there we go. We're all done. We're all finished. So now we're going to take these resistors from the output of the pick to the base of each transistor, the base being the center pin. So no matter which way around we've put these in, it doesn't matter. The base is the center pin, which is good. So we have our RA0, RA1 and RA2. So if you recall, those are the bits that I made a delineation line. So you want to go on the correct side of the line to the middle. The middle of your component. Bit of a stretch on this one, but it's okay. So that's about right. So I'm going to just hold that. Just tack that now so it doesn't run away with me. Ooh! Ooh, misses. Ooh, misses. It was a little bit warm. So you can see it's coming out of the microcontroller, hitting that leg of the resistor, and then jumping across straight to that middle leg of the transistor. Because you've got this parallel tracking, just bear it in mind that unless you specifically drill out a track here, it's that bit there is going all the way there and all the way there. You've got to be a little bit careful with that, because sometimes you might build something on the circuit over here and forget that there's still a track between the two, and then all of a sudden crazy things are happening. And the craziest sort of thing that happening is components blowing up and you have no idea why. So just be very careful as you're going along with these circuits and try not to sort of lose your way. Next one. There are other kind of board systems. There's some where you don't have the parallel tracking, you just have them basically all single pads, and you have to wire between everything too. There's loads of them really. Point-to-point wiring works pretty well too. There you go. In most cases, like simple cases like this, point-to-point wiring would be probably quicker. You don't really need to think then about where the tracking's going, and then cutting all these channels, the little holes out. Right, that's it. That's our microcontrollers going to the base of each transistor. I went quiet there because I was just sort of focusing a little bit on what I've done, but yeah, that's fine. So you've got effectively like your R, your G and your B. So let's look at our circuit. So what we need to do is now hook the emitters up to a common 0 volts. And the emitters are these end pins. Yeah. So if I flip it over, so you can see the diagram there, if I hold it exactly the same, the emitters are here, here and here. So if I flip it that way, you can see that the emitter pins, this is 1 emitter pin, 2 emitter pin, 3 emitter pin. So all these tracks have to go to ground, and our ground is here. So this is a common ground between not only the PIC, but also the 30 volt side of the circuit. So we're going to have to make some jumpers to go across there. Now there's lots of ways of doing this, and you can get specific wire for doing it. I am going to do something maybe with these component legs. They're kind of a bit short, but we'll do the first one at least. So this is a bit of component leg offcut, and depending on the sort of components you've been working with, you might have quite a lot of this. But we know this one's an easy case because you're just jumping across these couple of ones. So I'm going to just decide where I want to be. Somewhere from here to here. Yeah, so if you can see there, those 2 pins, that's really where I want to be. But I'm going to move it in away from the edge. If you're doing this yourself, just move them away from the edge, because you don't want them right on the edge in case you want to retask the edge for something else. So I'm just going to hold that there upside down. And I can see that again is one of the tracks. Oh, that was hot. That I cut, that I didn't really need to. So that's the ground there. You see that second one in that's cut. Now I don't think we can, so we're going to have to again make a jumper for that one. If it's very close, you can sometimes just bridge it with a blob of solder, but that's not good practice anyway, so we shan't be doing that. And there we go. You can see it's quite handy actually. I'll just show you. You might just be able to see their ground GND on the board, and that's it. So it's clearly marked. You can't really go wrong. Now the booby boards do allow for there is an pardon my French. There is an unregulated voltage rail, which is the very end voltage rail. That's a VN. So technically we could hook up to that and hook the 30 volts to that, and the booby board could derive its power from there. But because we don't know really what we're dealing with right now, and I can't quite remember what's the regulation on the booby board, and I might want to hook it up to the USB, it's best just to keep those 2 circuits separate for now. The booby board does have an onboard regulator, but I can't quite read it. But yeah, I'll get the spec for that. It's definitely a 5 volt regulator, but from what to what. Okay, so that's our first ground to our, and double check again, emitter of this one. So we just have to hook the other ones up to the same thing really. So you've got lots of ways. I'm just sort of looking at this, umming and ahhing, going, yeah, there's like cheats, for example, like say, that's good. So that's basically where I have to solder this one, and I don't really have enough wire. That's why I'm trying to avoid putting it in the hole. But you can see I could technically just solder it from the top, and I think actually I will. So So I'm just going to put this wire over there. That's where I want it. So I'm just going to put that blower solder there. I mean, this is the sort of trick that you're going to do anyway at home, isn't it? You're going to cut corners where you can. It's fine. Electrically, it's exactly the same. I'm going to touch this one up there because it's nice and big bit of solder on there. That's not going anywhere. So that's the two now, the two emitters. First emitter there, second emitter, just one more. And we're done with that. It's quite a nice little build, really. Can we repeat the same trick? Hope we can. Yep, that will do absolutely nicely. So it's up to you how much pride you take in your PCB work. Under most circumstances, I probably wouldn't want to be doing it this way. I'd be a little bit embarrassed if someone sees that, but it's between you and I. I'm doing it as a sort of teaching you how to do it. Yeah, that's not how I normally do it. No, so that's fine. So you've got all the emitters connected. So we've got that bit done. We've got that bit done. So really, it's just the LED. So you can see you've got 30 volts somewhere that goes out to the LED, and then you've got the LED coming back. So what we're going to do is solder something again to that common ground, which is right here, if you recall. I'm going to solder this because we can use this elsewhere. I'm going to bend it a dog egg, make it 90 degrees, because we're going to need a few probes. I could use some ribbon cable. If you've got ribbon cable, just go ahead and use a ribbon cable if you want to do a sort of nice permanent looking thing. It's good stuff actually, ribbon cable, but remember it's not quite nice to, it doesn't react well with heat. So if you're soldering it, you want to be very quick. So we've got that, this is the 0 volts basically, that's a common, that's fine, that's going to go elsewhere. And then we just need the channel that goes to the LED or whatever coming to here. So I'm going to use this orangey wire to represent red. So we're going to take the red from the collector of our first output here, which is the one that's driven by AN2, and the collector being this pin here. So just to show you, that's this end pin here. So we're going to just hook our red there next to it, and if I'm lucky I might be able to find a few other colours that we can use. Be back in a sec. Right, found some different coloured wire, but not ideal. So I've got two reds. One represents the power in and the power out from our bench power supply. The black represents the negative from the bench power supply. So this is all the 40 volt side of things. And the black is actually there to provide a common ground reference to our booby board. And then we've got the red, the green, and the pretend that's blue channels that'll hook up to our module. So we can just go ahead and solder those up right now. So pretend the yellow is the blue. And I'm going to do it quite gingerly. I'm not going to cut these or anything like that. The probes, so you can see they're quite long, like that, just sort of jumping in across the PCB. The green, right there. Just be careful you don't want anything to short. If you're doing this permanently, obviously just cut them short so you don't short when you do that, touch them down. And then the red, represented of course by our orange wire. And the reason I'm keeping these just like that, because in all likelihood I'm going to want to have quite a much longer sort of wire set up here eventually, and but not today. And then we've got the final wire, of course, which is our positive. So that's all of them, all hooked up, looking fine and dandy. Just sort of wondering if there is a way we can sort of test this a bit. There is, and I'm going to be a bit cautious because we don't really want to blow out our booby board. And so before I just turn on that bench power supply, I'm going to flip it over. The booby board is not connected in any other way other than those 3 pins, and the booby board itself, and the ground of course, and the booby board itself is not receiving any power, so we shouldn't see any action out of a booby board, but we should see possibly a tiny glow out of these. Nothing just yet. Okay. Maybe get my multimeter out, see what I've done. So this is the sort of thing that happens all the time now. So you'll set it all up and then you'll find there's something not quite as you expected it. So that's pretty standard. So let's just check there's power there. Huh. Interesting. Quite confident we'll be seeing power. Oh, there we go. So that's the R, the G and the B just coming on right away. I've got a current limiter on here. I'm just going to turn the voltage down so we can see what's going on there. Yeah, interesting in that I didn't expect them to come on right away. So I'm going to have a quick investigation to make sure I've hooked up the transistors as expected. I would have kind of expected them to be all off, but yeah, it's quite pretty, quite nice to actually see those. I think it's not an actual problem. I think it's just because we haven't pulled everything tight to ground. So if I put, you see on these resistors, so if I bridge them to ground, you see how they're effectively going off. See if I can get all 3 in one go so we can kind of simulate this being kind of off. We're fighting, it's fighting me. But yeah, you can see that there. So I think once we get the pick active, we'll be able to see something there. There we go. Phew, thought I wired it up wrong. So I think that's a good point in time to draw the line, because the next stage now is actually doing the whole microprocessor programming side of things. So in this episode you learnt how to actually do a bit of Veroboarding and create the circuit freeform on the bit of Veroboard, and then actually attach that up to your microcontroller board. So we're pretty much all set for hooking this up to a computer. How exciting. Please like, share, subscribe, and definitely, most definitely comment down below. And as ever, thank you for watching.